Let's look at who does what in the world of structural steel design and construction. Here's an example of a building. This is the Student Services building on the LCC main campus, Building 1. So that was designed by an architect. And when a building project is begun, the overall design, the whole idea of the form and the space, that is designed and coordinated by the architect. And then inside that building, once we have established what the spaces will be like and the form will be like, then we need to move on to engineering. And so here is some of the structural steel framework inside Building 1 while it was being constructed. And the designing of this work is done by an engineer. So the engineer will be a consultant to the architect, or sometimes they'll work in the same firm. In the design and construction process, then, the design happens with the architect and the engineer. Then the design is passed off to a steel fabricator who actually will cut the pieces and punch the holes and paint the part numbers on them and send them to the job site, where the contractor, whoever that is, will erect these steel assemblies, weld them and bolt them together. Now, what about the drafting role in all of this? In structural steel, drafting is known as detailing, steel detailing, and here are the kinds of jobs you might do in the world of steel. So if you work for an engineering firm, you will not be doing shop drawings, but you might be doing design drawings. The architect and engineer will do the original design, but you might work out some of the details in the design drawings. I think we have a couple of engineering firms here in town where drafters are doing some of that work. If you work for a steel fabrication company, that is the company who cuts the steel, punches the holes, and all of that. So that's a fabricator, and they need shop drawings. So drafters work for steel fabricators, creating shop drawings so that the holes can get punched and the angles can get cut. Then if you work for a contractor, you might be doing the erection drawings, where you're labeling what parts go where and in what order and that kind of thing. Design drawings, and again, these are not shop drawings, these are the design drawings where we're thinking about how does the framework go together. These design drawings are usually single line, and they show the pieces of steel assembled together. And you can see some labels here. And then these design drawings can get used by estimators who are preparing bids. They can be used by the steel detailer who works for the steel fabricator. Now, we try to keep our spaces in our structural steel framework real regular, so we divide them into what are called bays, and the bays have columns at their corners. This relates to the grids that you already know about. A commercial building, and especially a high-rise commercial building, has just thousands and thousands of pieces of steel. So the more we can make these bays modular, so many of them are the same, the less inventory we'll have to carry and the fewer drawings we'll need, and the easier it will be just to assemble the whole thing. So these column center lines that make the corners of the bays become these grid lines. And you already know about these grid lines. We've seen these before. Every drawing in the set of structural steel drawings will use these grid lines. Here's an example from the National CAD standard. and we make them thin, like on a dimension line layer, and these lines run through the entire building. So this column in the middle of this sample drawing happens to be column B2. It's at the intersection of grid line B and grid line 2. So that's B2, and good old B2 will show up on every drawing and in the column schedule and so forth. When you're figuring out where to put these grid lines, try to start them off of some baseline that exists in the real world, in the physical world. So you might not want to make this corner out here the start of your grid lines, because when we start laying out our grids up here, there's nothing there, it's just air. So we try to find something physical if at all possible. And you can use fractions of a grid line, as we've seen before. So you could have a grid at 2.5, for example. By the way, when you're numbering and lettering these bubbles, the National CAD standard says do not use the letter O in these alpha characters, and do not use the letter I in these alpha characters, because they could be confused with 0 or with the number 1. So you just skip O and I when you're doing this. All right, so design drawings and grids.